It's very interesting to be talking about artificial intelligence with you because every single speaker, as far as I've heard, until now, has given you examples about AI or have touched upon AI, either the implications or practical use cases and really cool breakthrough applications of AI, etc. So we're going to do things a little bit differently to start off with. And I'm not going to rattle off this long list of amazing things you can do with AI. We're going to start at a different end. A few months ago, I was talking to an author who's writing a book about the future of technology and humanism. And he said that he had been at about 300 or so technology conferences over the course of a year and a half. And he said that these are the people who are shaping the future. And yet not a single one of those speakers had ever mentioned the word love. And so first of all, I thought, well, challenge accepted. I'm going to be talking about love. Secondly, I thought, actually, it's not that far-fetched to be talking about artificial intelligence and love. Why is that? Well, because one of the really fascinating things about AI, or this idea that we can have machines that are human-like or that think or are as smart as a human being, that makes us question, right? What does it really mean to be a human in this world of artificial intelligences? And really, love, whether it's to a partner, to a child, to your colleagues, to the world, the environment, love is one of those things that makes us feel alive, that makes us feel human. Also, when it comes to artificial intelligence and love as a topic, we have a plethora of movies, science fiction, right? And science fiction is one of those really interesting ways to predict the future. And it's always a fascinating question whether the science fiction authors are really the ones leading the way for technological development or vice versa. And so if we look at AI in science fiction in combination with love, we found a few really, really interesting movies, right? Like the movie Her. For those who have seen it, Theodore falls in love with his artificially intelligent operating system. And for those who have seen it, and for those who haven't seen it yet and will see it, notice at the very end where Samantha has to leave, right? Notice the conversations there, because it has a really interesting premise for what the future of AI might hold. And I won't tell you more because I don't want to spoil the movie. For those who haven't seen it, pay attention to that detail because I find it deeply fascinating at a somewhat philosophical level. Other movies, right? Ex Machina, where, and I assume most of you are familiar with the Turing test, right? Or how to assess human-level conversational intelligence in a machine. Ex Machina kind of proposes a next-level Turing test, which is, if you can make a human being fall in love with a machine, well, then it's at human-level intelligence. And it's an interesting premise as well. And then, of course, there's this episode, which is probably the only feel-good-ish episode of Black Mirror, where basically AI has a really, really important role to play in the future of love. So we have this kind of abundance of that theme, artificial intelligence and real love, human love. But I want to take it a little bit more concrete, a little bit back to the moment, from science fiction and down to reality. We are in the middle of an AI revolution. There's every single speaker mentions it, and that is for a reason, right? It's not just a hype, it's happening. And why is that? Well, it's a combination of two factors, right? One is that we have access to more computational power. Post about 2012, we have access to enough of it so that we can actually apply these algorithms that's been around for a long time, right? So 2012 was the breaking point, and then of course it took a few years to catch on in media, etc. What that means is that today, two girls in a garage can kind of fire up an Amazon instance, throw on some open source code, and actually have a running machine learning project that can solve a real problem. Well, 20 years ago, you had to be a professor with access to a supercomputer to do anything of the kind, and you don't build a business from a university supercomputer like that. The second thing is, of course, access to data. Thanks to the internet, everyone has access to enough data, depending on what you want to do, to train these algorithms. And so that's the starting point, right? Those two things in combination is enabling this revolution. And I think it's also important, and this is becoming more and more common knowledge, but I still want to say it out loud so we kind of all agree that AI is a very fluffy term, and we really talk about 3 levels of AI, right? We have this idea of artificial superintelligence, right? This idea that at some point, an AI or a machine is going to be as powerful as all human beings combined, right? And we don't really know what's going to happen at this point, and it is really, really far into the future. The learned people of the AI world massively disagree about when it's going to happen, so we're not going to go into that discussion right now. People way smarter than me have absolutely no idea. So that's the kind of the long future. Then we have what we call artificial general intelligence, or this idea that one machine can be as smart as one human being. That is also quite a while into the future, and I'm going to touch upon later what that might entail. Like, what do we have to do to get there? Because there are some fundamental breakthroughs we need to see happen before we're going to get there. And finally, we have artificial narrow intelligence. And when we kind of talk about AI from a business perspective, like a business strategy perspective, it's narrow intelligence we're talking about right now, right? So like AI systems or machine learning algorithms that can do one thing and one thing only. And they do that thing really well, way better than a human in a lot of cases, but it does only one thing, right? So if you call up your bank and they have this automated voicemail that kind of recognizes your voice and sends you to the right person, if you ask that machine, like, hey, what's for dinner? Or like, how do I cook, paella? Or whatever it is, right? It's not going to tell you that because it is only trained for one thing. I also really I'm a big fan of explain it to me as if I was 5, if you know that concept. And I'm going to do that again. From what I hear, about 98% of Spanish businesses has applied AI to their business. So I'm going to assume that you all know quite a bit, but I still want to do this kind of very, very basic. What is AI machine learning? And how does it differ from kind of regular software? Because really, AI is just software, right? There's nothing more magical to it than that. The difference between regular kind of traditional software and AI-based software is this. Regular software works more like a calculator. You give it A plus B, you get C every time, right? It's pre-programmed to give you that answer. It can calculate large amounts of data, et cetera, but it always gives you the same answer. So it's more like a calculator. While an AI system or a machine learning system, based on the data it has seen, it will refine its answers. So you give it A plus B one day, you might get C. You give it A plus B next day, depending on what data that has been run through the system, it might update its answer because it's been smarter, because it's been exposed to more data, much more so like a human brain. Like, we can change our mind, we can learn more, we can understand more finely concepts or whatever we're dealing with. On the topic of machine learning and AI, you'll hear me using those two words a little bit interchangeably. And and this is making a little fun of our own scientific field here, but I did want to share this with you, like the difference between AI and machine learning, that if it's written in Python, it's probably machine learning. If it's written in PowerPoint, it's going to be AI. And I'm going to use the term AI, but really AI is this, as I said, it's a big fluffy umbrella term, right? It was coined in 1956. We don't really have a clear definition of what it is and isn't. It's being used in everything from this, Terminator, supercomputer that's super intelligent, all the way to hey, I put this little machine learning algorithm on this little piece of text, and I got this other piece of text out of it, right? That's kind of the span of it. And AI today is fairly synonymous with machine learning. Machine learning today is fairly synonymous with neural networks. That is the main approach to machine learning. And neural networks, when we talk about that today, really, we're talking about deep learning, right? 50 to 60% of all R&D budgets go into deep learning. So it's really the main breakthrough right now. And that's what's enabled all of this image recognition, for example, to a large degree. And there's other fields as well, but this is kind of the gist of it. What's interesting is this, right? neural networks were first proposed in 1958. We're not talking new technology here. Deep learning was first proposed in 1986, right? This is not new technology, but computational power and access to data means we can actually apply it. And I wanted to give you kind of a very quick example of how a neural network functions. And again, this is on a very, very kind of basic level. And I talked about how a machine that learns is more shaped like a human brain. And it's a flawed image, right? For a couple of reasons. First of all, we don't really know how the brain works. And there will be speakers talking about that later. But we don't fully understand how the brain works, so we can't really shape our systems after it. Secondly, do we really want to make machines that do exactly what the human brain does? We'll talk a little bit about ethics later, but fact is that our brains are ridiculously limited, right? As amazing as they are, they're full of biases, right? We recreate, like when we have a memory, about 20 or 30% of it is stored, right? The rest we kind of just like recreate because we assume that was what happened. And if you want to look more into that, there's this experiment about the lady in the red dress and how, if you're asked repeatedly, well, do you remember the lady in the red dress in that scenario? If you're asked that repeatedly, eventually you're going to remember the lady in the red dress, even though she wasn't actually there. So we kind of recreate. The point being that we don't want to make machines that do that, right? We want to make machines that are complementary to our human brain. But again, as an image and as an example of how machines learn and how they work, it's nice to use the brain as a way to understand it. And a human brain has neurons that are the computational units and synapses that send the signals back and forth between the neurons so they can compute. Much so with a neural network. And I'm going to give you a simple example. Let's say that I own a little shop that sells those pastries, the churros, right? The churros with the chocolate sauce. If I've ran a churro shop, I don't know if that's what they're called, if I've ran that for 30 years, I'm going to know, right? Like how much dough should I make in the morning, right? Now, I don't want to make too much because I might have to throw it away. I don't want to make too little because I want to have enough for all my customers. If I've ran the shop for 30 years, I'm going to know how much to make, more or less in the morning. Same with like melting the chocolate. But if I just inherited this churro shop and I'm like, okay, I'm going to start. Good morning. How much am I going to make? Well, I might have to get access to some data. Let's say that I get access to a data set that tells me how much this shop sold every day for the past 4 months. I also have a data set that talks about the weather. Is it cold? Is it raining? Is it a really, really, really warm day? And I take those data sets, and I'm pointing now at the pink dots on the screen, for those who can't see my hand. You take those data sets, the input data, and I send that over to this hidden layer of neurons. The white ones are the neurons. And I send that data in. And I have the machine calculate for me each of these data points, and the output, the orange dot, is this is how much dough you should be making today. Now, the interesting part, right, which is where you train and adjust do what is called hyperparameter tuning, etc., is that you adjust this because is it more important that it's Monday? Is it more important that it's raining? Or is it more important, what is the most important part? Like, you weigh the different inputs so that you get the right output. And as this, and for the first day, I put this data in and I get a recommendation. Now, every single day, I'm going to plot in the weather and how much I sell. And over time, this machine is going to learn to give more and more precise answers to how much dough should I make this morning. And maybe I'll overlay it with, I don't know, Real Madrid playing a football game nearby. That might affect my sales. I'll overlay it with public holidays, et cetera, and you can feed more and more data into the system, get more and more refined answers. Simple as that, right? Of course, this is a basic example. Like, I could probably sit down with an Excel sheet and do this calculation on my own, right? Maybe not quite as accurate, but I could probably do that. That's where deep learning comes in, and especially so in image recognition. And again, simple explanation. What happens here is that you have multiple of these layers of neurons, these computational units. And so what you do is you feed this. So this is an image, a deep neural network that has been trained on, say, 1 million or 2. I don't know the exact data set size, but they've been trained on images of cars. Now I send this neural network a picture of a car it hasn't seen before, so it doesn't have a label for it. It doesn't know what it is. And what the first layer is going to do, the one with the actual car on the side, that is going to recognize some patterns, right? There's a darker area here and there's a lighter area there, right? So it might be a line. You send that information to the next level, it starts recognizing that, there's this circle. These little lines form kind of a circle. Next level, and you send that on. And every level kind of finds a new pattern until the very end where this network is able to tell me that this is an Audi A7, which is far more than I would be able to tell on my own. And that is the basic functionality. You basically have multiple layers. And at this point, we're up to being able to handle 150 plus of these layers. Usually you don't need 150 layers, it's way too much, but we can do that and we can handle that. And that is one of the things that's caused these massive breakthroughs, for example, in image recognition. We'll get back to that in a second. So really, AI, machine learning, much like regular software, is a combination of hardware. And there are some differences in infrastructure and hardware when it comes to AI as opposed to regular software. For example, there's quite a lot of interesting stuff happening in moving from CPUs to GPUs that are originally made for gaming and graphics because it's just more powerful. We're not going to get into quantum computing and a variety of other interesting breakthroughs, but the hardware is important, much like in other software. Then you have a piece of code, algorithms, right, scripts, and then you have the data. And we talked a little bit earlier, right, about this getting to artificial general intelligence. And in order to get to AGI or closer to AGI, we're going to need, and I'm going to explain why in a second, but we're going to need some fundamental breakthroughs in some scientific areas. Now, depending on what scientist you ask, that's going to look very different, right? If you ask a physicist will say, well, we're going to have to see some major breakthroughs in physics before we're going to able to get to AGI. Ask a mathematician, they're like, no, there's some serious mathematics, like new theorems, like new fundamental math that we have to discover and understand before we can get to AGI. Ask a neuroscientist, and they're going to be like, no, we're going to have to fully understand the human brain before we get to AGI. They might all be right. I don't know. But fact is, we're going to have to see some breakthroughs. Why? Well, because of this, right? So you have hardware, software, data. That means for every single use case, you have to set up an infrastructure, build code, and add the data, specifically for that data. One of the kind of holy grails of AI machine learning is to say, well, we're going to have the same infrastructure, we're going to have the same code, and we're going to give this machine an entirely different set of data, and then it's going to learn, right? So personally, in my company, we're building an AI scientist, right? An AI that can read scientific text. And this idea is like, well, sure, it can read scientific text. Let's run a cookbook by it and have it prepare us a meal, right? That's, you would expect that from an artificial general intelligence, right? It can learn anything and do anything. I promise you our AI cannot read a cookbook and go cook a meal. And that is one of the holy grails where we have no idea how to achieve that, and we're going to have to see some mathematical, physics, neuroscience breakthroughs to achieve that. Again, deep learning, 1986, right? It's old technology applied, and I mean, obviously there's been breakthroughs happening in the last few years too, but those fundamental concepts are old. Another thing that's going to be really important is you have hardware, software, and then you have the data. And we've been talking about big data now for, I guess, a decade or so, right? Big data. Everyone talks about big data. Big data is the way to get ahead and your competitive advantage and all of that, which is totally true in today's landscape. The challenge is going to have to be building AI systems that can get by on tiny data, right? Now, one of the reasons for this, one of the really tricky things, so let's take a toddler, right? We usually compare these AI systems to children that have to learn. Like take a 2-year-old child. How many cats does a 2-year-old child have to see to learn that that's a meow, which is what we say in Norwegian? They might have to see like 5 cats, maybe 10, 15 if your kid is a little slow, right? And then they know that that's a meow, right? And they know that that thing over there is a woof, as we say in Norwegian. It doesn't need to see that much data to learn. Now, an AI algorithm needs lots and lots and lots of data to learn, right? It needs to see 1 million cat images, which is not a problem when it comes to cats, because the internet is filled with cats, so we have all the data we need, but that's not true for every business case, right? Fun fact is that when it comes to cat image recognition, or image recognitions at large, right, it's been one of those things that are really, really hard for a machine to learn, right? Because how do you describe a cat, right? It's got pointy ears, like a cute little nose, it's all furry and fluffy. Well, so are dogs, right? And guinea pigs. But it's like skinnier than a guinea pig, unless it's pregnant, right? So there's all of these exceptions, and it's really hard to like codify what is a cat. So it's been traditionally a silly example, but one of the hardest things to learn for a machine. However, per last year, machines have about a 3% error margin, right? 3% of the time they get the cat wrong. Human beings are at 5%. So machines are better today at recognizing that a cat is a cat than a human being. But again, they have to see 1 million or more images, while a human being needs to see like 10 cats, and they're good. And I want to give you an example of how quickly this is going. I'm going to use images as an example again, right? So in 2006, July, I was in Corfu with my friend Maggie, and this is the last physical image album that I ever printed, right? And so what happened since I printed this one in 2006 were a few things. First of all, I got a digital camera, right? I replaced my old, film camera with a digital camera. Second of all, I ditched my own old digital camera and I replaced that with an iPhone. And thirdly, in 2016, Apple launched their deep learning algorithm that runs on your phone, categorizing your images. So while 2006 and before that, I had to go into every single one of these, and luckily I labeled them, right? I was a very organized, youth. Before then, I had to go in, I have to look at every overview, and those overviews are really neat, right? Because I didn't have to look through every single photo, but I had to go through every single album to find that one picture I was thinking about. Fast forward 2016, so we're talking 10 years, right? Not a digital camera, iPhone, deep learning algorithm. And now, on our phones, we have this, where you can input Christmas tree, and you see every single photo you've ever taken of a Christmas tree, right? Skyscraper, every single photo I've ever taken of a skyscraper. Guess what? Cat. Every single photo I've ever taken of a cat. And I was preparing this presentation, and I was fetching this, and I look at the screen, and I go, wait a minute. And I don't know if you can see it on the other side, but 1, 2, 3, 4, 5, and down to the left, I'm like, that's a dog. That is not a cat. And I open that photo, and turns out there's 2 things going on, right? First of all, sure, it's a dog, but there's a little, seemingly a little cat doll in its paws, right? There's also a joke about a cat, and I'm like, I don't know what it is this AI is picking up, but it's doing it better than me. All right, being a little bit upset by Apple tricking me, or being better than me, I guess, I picked out a video of Apple failing that I'm going to show you, and there is a reason why I'm going to show you, but let's look at the video first. This is a video from 2014.
Switch off iPhone.
Change what?
Turn off the phone.
Which setting?
The power setting.
I don't know what you mean by the power setting. Turn off what?
Phone.
Call who?
No one.
Okay.
So, the early versions of Siri weren't all that great, but remember what Jeff said, right? This is the worst it's ever going to be. And this was 2014. Fast forward a few years, and I'm not going to show you Google, which is not a comparison between Apple and Google. It was just, a good video. And some of you might have seen it. It's from Google's I/O conference last year.
See, how may I help you?
Hi, I'd like to reserve a table for Wednesday the 7th.
For 7 people?
It's for 4 people.
4 people? When? Today?
Next
Tonight?
Wednesday at 6 p.m.
Oh, actually, we leave there for after 5 people. For 4 people, you can come.
How long is the wait usually to be seated?
When, tomorrow or weekday or?
For next Wednesday, the 7th.
Oh, no, it's not too busy. You can come for 4 people, okay?
Oh, I gotcha. Thanks.
Yep. Bye-bye.
So there's a couple of reflections, right? One is that it is amazing how human-like a robot sounds when you add some that's just a cheap parlor trick, really. But the ability to understand the flow of a conversation is unprecedented. Keep in mind, too, that they probably had, 10,000 of these calls, and this was the best one, right? So we have to, be mindful of a little marketing. But it's still freaking impressive. And that is a speed, 2014 to 2018, 4 years. So how is this going to sound like 4 years from now? Right? How are those conversations with these AI bots be 4 years from now? Think about that. And think about your AI strategy. So I hear that 98% of you, as I said, are already doing AI in your company, which is great. Alphabet announced as well that a year or so ago that they were going to be AI first, right? In 2010, they said mobile first, and it was a big deal. How many people today have websites that don't work on mobile? Good. So Google kind of had it right? And now they're going AI first. And so should, to larger or smaller degrees, everyone, or at least consider your AI strategies carefully. Now, I've categorized AI strategies into 4 buckets. There might be more. If you can think of more, come tell me. But these are my 4 things that I've observed, both in big corporates and in tiny startups, right? There are 4 kinds of AI strategies. First one being labeling. And it goes a little bit like this. Upper management tells a middle manager, we're going to have to do some AI. Middle manager does the right thing, goes out and checks with the organization, what is our tedious, most manual, boring, time-consuming process. Finds that, goes to that department and says, hey, we're going to build this AI software that's going to replace your jobs and it's going to be awesome. Not in those words, but that's the essence of the meaning. Those people there do what some people at SU refer to as this, I am blanking on the word, when your immune system, right? They do the attacking with the immune system and basically, destroy the whole process, making sure this project never comes alive. So this middle manager, being measured on their KPIs from doing this AI project, goes and finds some other random project and says, sure, we can do some AI in this project, and puts an AI label on the project, and boom, you've got an AI strategy. Needless to say, and I've seen this in organizations, this is not uncommon, right? Because you have to deliver some AI, so you find some projects, and you call them AI projects, and we're all good. Needless to say, it doesn't really work. Second of all is branding, and I've seen this too. Some of the biggest companies in the world have done it, right? Going out with this big, massive marketing campaign, making these massive promises about what their AI and machine learning can do. And fact is, when it comes down to it and you see the actual results, it's very, very underwhelming. My company, we've also been in this situation where we've had big corporates present the collaboration with us on international stages and talk about us, yet they've never paid us a single euro to do anything, right? So you have this brand, you want to be seen as an AI company. And there's nothing wrong with doing some branding around what you're doing. Make sure there's something behind it. Then we come into the more real stuff, let's call it that, which is the problem solving, right? What are the things we can solve in our current processes or for our clients using machine learning? You go in and you have all of these little projects that you do where you can actually let's say increase the profit margin with a product of 3%, or make your process 10% more efficient, things that are going to matter a lot for the bottom line of that project or that process. And that's really good. That is really cool. Then there's a fourth way, which is the vision, which is saying that, you know what, 10 years from now, 15 years from now, this is where we're going to be, right? And it's different from the branding because this is internal, right? It is setting a goal for your entire organization, going, this is our moonshot. And I would say that the interesting combination is to do the vision and the moonshot and connect that to those little problem-solving projects. Taking that moonshot, having a goal, a clear vision, and combining that with a nitty-gritty, day-to-day, what part of your organization has the most tedious manual process? What problem are they solving? Who are they solving it for? What data do you need to solve that problem? And what answers do you want from that data? And finally, what of that can you do with this existing machine learning AI, and what needs R&D? And I mean, this is basic innovation 101, right? There's nothing magical about it just because there's a little AI machine learning involved. It's basic problem solving innovation. Connect that, though, to the big vision. Never lose sight of where you want to go. Obviously, you want to pivot every now and then, and your strategy might change, but make sure you keep that in mind as you solve all of these little problems. Keep in mind, too, that human progress, this is from Tim Urban, and you've seen this curve a lot of times before, right? When you plan out the little problems that you want to solve in your company using machine learning, keep in mind that that big vision is going to be, a possibility because this is what's really going to happen, right? The technology is going to keep up, even though the technology you currently have at hand doesn't look like it. I'm going to quickly, I have a few minutes left, and I wanted to quickly touch on some really, really tricky questions, because that is the case when we're dealing with AI. Because, as I said already, our human brains are incredibly limited, right? We have an enormous amount of bias. And fact is that an AI is no better than the biases of the humans who designed it. And we see this in case after case. For example, in the Florida police district that made a screening algorithm to determine whether or not someone was likely to be a repeat offender, turns out the algorithm is racist. And there is a whole complex world of data behind that. Basically, if your skin is dark, you're more likely to be a repeat offender, according to this algorithm. Highly problematic. Is it more or less racist than, say, a Florida judge? Good question. Another thing, just because something is statistically true doesn't make it right. What that means is that if we base our future prediction on historical data, we're going to be in trouble, like Google's algorithm showing job ads for executive-level positions to 1,800 men and 600 women. Why? Well, it's statistically true, right? There are fewer women than men that have those positions. So statistically speaking, they're reaching their right audience, but that's going to impact the future. And these are the things we need to be really, really mindful of. Finally, personal data is complicated, right? Now, we live in Europe, we have GDPR, we feel like it's a little bit of a hassle, but we're protected, right? I own my data. No company is going to come take my data and do what they want with it. And I wholeheartedly agree with that. But then we get into a situation like this, that Facebook can accurately predict suicide from your posts and your videos. There has been instances in the US where Facebook notices something off on a live stream or a post, sends out a dispatching unit from the emergency services and prevents someone from hurting themselves or others. So a really brutal question is, if your 18-year-old daughter is about to commit suicide and Facebook knows, do you want them to tell you? Right? It's complicated. Do not give weapons to autonomous systems, period. For those of you, this is again Black Mirror. The episode is called Metalhead. for those who haven't seen it and go, well, there might be examples of how we could give weapons to robots, and it wouldn't, like, go watch that episode and then come back to me. And so what we need are these ethical frameworks, boards, ethical groups to consider what we're doing in each separate company to assess, how we best can go about it. And there's a variety of people working on this. Accenture has a framework, and that's a picture of here. PricewaterhouseCoopers also have developed a framework for ethical AI, etc. And fact is, right now, we've made it to the starting line. Right? We're not at this end game. We're now like at the starting line. This is where it all begins, right? We're already like, I have a friend who tells Siri, "Good night, sweetie," every night. He's very, very single. Every night he tells her good night, and she says good night back to him, right? We're already doing this. We're already using Tinder and all these dating apps that have machine learning AI algorithms in them to help us find a more compatible partner. And I'm unfortunately going over time here, so I'm not going to be able to dive in, but I want to very, very quickly take you through some of the things that I find fascinating about AI. Chatbots that can give you personal, consolidated advice, let's say on your finances across your bank account, the status of your car, the fact that you're getting married so you need to save up on your honeymoon. Not this stupid, when is the bank open, but personal advice. Having one tutor, one AI tutor for every child, following your child through their entire childhood, knowing what they've learned, how they learned it, and how they learn best. Doing the same for you, getting you off of your butt and out to the gym or the woods or wherever you want to go work out to prevent lifestyle diseases. Predicting outbreaks of really, look at the Ebola crisis, right? If we can have AI systems that can predict these outbreaks, we can manage disease much better. Autonomy in healthcare, microscopes that can actually read your results and give you an answer on the spot without a single doctor being involved. And this is a microscope that already exists and is in the field. Researchers, like an AI researchers that we're building. Of course, autonomous systems, self-driving cars, etc. And finally, logistics, like every single boring task that Jeff Bezos has done. Like, he does all the boring work that no one else wants to do, and he's the richest guy on the planet, right? Not that that's a goal. But all of those boring logistics, they're going to be managed by AI. So finally, I just want to wrap up with this, that I know that the future is a little complex, and you're going to be a little bit mind-blown and a little bit shaky when you go out of here this afternoon. But if we can build AI systems that are not just shaped like the human brain, but that we also bring our hearts and a little bit of human love into it, I am pretty sure that we can make an incredibly beautiful future. Thank you.